Hi John, this is Sarah. I figured out the problem, but it's really hard to explain with just text, so I decided to send you this video with my work, and then I'm going to explain my work a little bit, and maybe that'll help you out a little bit more. So I basically took the answer on D2L and I kind of deconstructed it a little bit. I'm going to run through it real fast. So the first thing I did was I started with the initial circuit, which is right here, and then for each one I made the equivalent circuits that they made you do in part A, which they have right here. Like I combined C1 and C2 that were in series, and then I combined the two that are in parallel right here, and then I just created the last equivalent capacitor right here. And then the first thing that I did for part B is I found the charge on the equivalent capacitor. So we know from part A that C1234 is 3/5 of whatever that capacitance is. So using the formula Q equals CV, we know that Q1234 is equal to C1234V. Now the reason why this V doesn't have any subscripts is because with this capacitor right here, we're gonna have that voltage, like the voltage that is right here. That voltage is the same across each one, but because there's 4 capacitors here and there's only 1 capacitor here, we can be assured that this voltage is gonna contribute to all of the charge because there's only 1 capacitor here. So the charge for capacitor, like the charge for this circuit up here is 3/5 CV. So we're going to use this number to help us find the voltages for each separate capacitor, and then you can get the charge of the 4 separate capacitors just by adding C to your answer. So that's pretty much what we're going to do here. So coming back to this capacitor right here, it's in series, and it's a breakup of this one that's C1234. It's in series. We have C123 up here and then C4 down here. So C4 and C3 are in series, so that means that Q1234 runs across both of them. So that means this charge and this charge are going to be equal, and the magnitude of that charge is going to be equal to Q1234. So down here I used some of the equations that they used in D2L. I said Q123 is equal to C123 times V123, but the magnitude of Q123, we know it's the same magnitude as Q1234. So over here where we found out that Q1234 is 3/5 CV, we just plug it in down here for Q123. And then this part is a little bit tricky because it doesn't really tell you this, but this is one of the answers that we found for number 1 when we're trying to calculate the capacitance for each of the series, for each of the capacitors. One of the steps that you get to, you will notice that C123 is equal to 3/2 C. So that's from part A, and that's something that's really easy to miss. And then the voltage for V123 is not going to be the same voltage as we have up here because it's split between the 2 capacitors. And because these capacitors are not in parallel, we can't make any assumptions about what's going to happen to the voltage because these 2 are in series. So coming back down to this equation, like I said up here, 3/5 CV is equal to 3/2 C times V123. We're going to solve for V123. So the first thing I did was I divided both sides by C. Since both of these C's don't have any subscripts, I can cancel them out. And then I just flipped the fraction and multiplied them together, and I got 2/5. So 2/5 is equal to the voltage for capacitor 123. So that would be the capacitor up here. And then coming over here, we have the capacitor split up again. This time it's in parallel. So that means that instead of the charge being equal across the two capacitors, the voltage is going to be the same across both of these capacitors. So that means that for capacitor C12, it's going to have the same magnitude of voltage as V123, which we found down here. So we said that for capacitor 3, we know that that's equal to V123, which I set up here. Since both of these are going to have magnitude of V123, this is going to be equal to V123, and this is going to be equal to V123. So V3 is equal to 2/5 V, and down here we have V123 is equal to V12, so again 2/5 is equal to V12. Now, since we have V3 right here, that's one of our answers that we're looking for, so I'm just going to box that real fast. There we go. Okay, and then the last step, coming up here, again, we split up C12 into these two capacitors that are in series with each other. So again, since they're in series, the charges across each of them would be the same. But in this case, since these are both in series with each other, the voltages have to add up to the voltage for V12. So in this case, we can say V1 plus V2 equals V12, and we also know that V1 is equal to V2 since both capacitors have the same charge. So right here I just did a little substitution and I said V1 plus V1 equals V12, so I added them together. The value for V12 we found, it's right here, so I plugged that in down here. And then I divided both sides by 2, and I got a voltage of 1/5 V for V1, and then since V1 is equal to V2, I got 1/5 V for V2 as well. Now again, so these are the answers that you would be boxing. Okay, so now we have a voltage for V1, V2, and V3. The voltage for V4 should be, I think I have it up here somewhere, hold on. Okay, maybe I don't. But what it should be is so like we were saying here, since C4 and C123 are in series, Q1234 runs across both of them. So that means that Q4 is equal to C4 V4. So we're going to run along those same lines right here. Again, we know that Q4 is equal to Q123, and the magnitude of that is 3/5 CV. So I'm doing that right here. And then C4, we know that that charge is just C, and again, we get that from the question, and it's really subtle, and that's the tricky part. And then V4 is right here, and then we solve for V4, and the only way that we can solve for V4 is if we just cross out both of these C's, and we get 3/5 V is equal to V4. Okay, so now we have all 4 of our voltages, and all we have to do to go from voltages to charges is we just have to add in our C's. So Q1 is going to be whatever V1 is, which is 1/5 V. So Q1 is equal to 1/5 V, and then because Q equals C times V, it's just going to be whatever this is, and then it's going to be times C. Now since V1 and V2 are equal, that means that Q1 and Q2 are equal, so this is also the answer for Q2. For Q3, we found that V3 is 2/5 V, so 2/5 V, and then just times C. And then for Q4, we already found it up here, but Q4 is equal to 3/5 V times C. So that's your answer. I hope that it kind of sort of shed more light on it than the D2L example. If you have any questions more about it, maybe call me, because I don't really know exactly how I can explain it any better over text. But anyway, I hope it helps. All right, bye-bye.